Okay, welcome back to another video lecture for Math 1316, Plane Trigonometry. And in this video lecture, we're going to be discussing the topics from section 5.2, which is the first section on proofs. And that specifically is the type of direct proof that verifies trigonometric identities. Now, this is a very lengthy topic. And it should be noted here that the strategies presented in this section are precisely that. They're strategies. It does not mean that if you do these things the same way every time, that you will get a result for your problem. So you have to exercise an amount of common sense, and we're presenting some of the strategies here so that you can think about them and then apply them using the identities that are given to you on your trigonometric identity sheet, and eventually go a little bit further into this and figure out some of your own methods for verifying different trigonometric identities. So when we teach verifying identities, section 5.2, typically this is just done with an absolute ton of examples. And so what you should be listening for here, because I won't necessarily write it on the board, are my thought process for how to work with each of the given identities. So to begin with, we're going to be verifying the identity that secant x times the sine of x plus cosine of x is equal to the tangent of x plus 1. So with any trigonometric identity verification problem, what we'd like to do is try to work, if possible, with only one side of the equation. Every identity is given as an equation, like so, and we're going to try to make either the left-hand side or the right-hand side look like the other side. Now, in general, we like to pick one side to work with, and I find that if you're just going to go directly into the problem and try to attack the identity without a lot of weird algebraic nonsense going on, what we want to do is try to pick the side that looks more complicated. So typically this scares people because they're like, I don't want to work with that. That's scary looking. But the scarier that it looks, it's actually better for you because you have more to work with on the left side than we do on the right side. Now you notice that the right side is tangent x plus 1, which is kind of like our Pythagorean identity, but the tangent is not squared, so we can't do any of the identities that we're familiar with right there to try to turn it into something else. What we're forced to do in this case is to look at the left side, which has more to work with, and see what happens when we do some algebra with this. Now notice that I have a secant x being distributed through a binomial containing sine and cosine. And so if I look at this, what I'm going to try to do, I'm going to run through a checklist in my head. And the checklist is, do I see any identities immediately? Well, I have sine plus cosine, but that's not sine squared plus cosine squared. So there's nothing that I can immediately do here. There's no reciprocal identities that are immediately helpful, quotient identities that are immediately helpful, Pythagorean identities that are immediately helpful. And I'm checking those three every time to see if I can find something. Next, I notice that all of the arguments, x, 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 and x, are identical. So that means we probably don't have any useful half angle or double angle formulas that we're going to use for this. So my immediate thought process will now be, okay, so in order to verify this, I've done all of the trigonometric things that I know how to do. So let's go to the algebraic things that I know how to do. And typically this is, can I factor something? Can I distribute something? Can I find a common denominator for something? And most of the time throughout these next couple of sections, those are the three algebraic processes that we need to check for each identity. So I notice that there's nothing that can be factored out because the left-hand side is already in factored form, but I can distribute secant of x through the sine of x. So distributing, I will have secant x sine of x plus secant x cosine of x equals, And then the tangent of x plus 1 will just be along for the ride. So now what I'm going to do is I'm going to run through my motions again. I'm going to start with trig identities, and I'm going to check, are there reciprocal identities that are immediately useful? And the answer is kind of. Are there quotient identities that are immediately useful? No, but when I'm talking about quotient identities, I'm also secretly talking about product identities, and there are product identities here that are immediately useful. And I would encourage you to think back to our lesson in class before we actually covered this section, where we talked about the hexagon for the trig identities, and you'll notice that we can create product identities that can reduce some of the terms in here. Now, reciprocal identities, we can notice secant of x, I should write this on a new line, it's actually 1 over cosine of x. And then the product identities, I can notice on my hexagon that secant times cosine is precisely 1. Well, okay, this is sine over cosine. This is sine times 1 will give me sine on top, cosine on bottom. So I've made this a little bit simpler. Let's check the list again. Are there trig identities that work? Reciprocal identities, we already did that, so I'm going to skip that step. Are there quotient identities that are useful? Well, yes, sine divided by cosine actually gives me tangent of x plus 1. And oh, look, that is precisely the tangent of x plus 1, which we were required to show. Okay, so I know that that's a very, very fast example, but I didn't want to stop and do a lot of explanation here because I wanted you to see what the thought process was, and then I wanted to talk about how I did that. So my thought process is always check trigonometry related things first. This is usually stuff like identities or the definition of certain objects, meaning what's the definition of the argument, what's the definition of sine and cosine, and so on. And then I wanted to, as soon as I've exhausted my possibilities with trigonometry, then I check the algebraic things. So the trigonometric things are typically in a higher precedence than the algebraic things, meaning I check them first. You will also notice that after I make a change, I write everything down on each line to the point where I caught myself when I was about to change this secant x. I write it on a new line. And what I'm looking for here, I'm going to rerun my checklist, starting with trigonometric things and then going to algebraic things when I've exhausted my possibilities at every single step all the way down the proof. Okay. What makes this section so hard is that you typically do something and then you have so many options and so many things to check that you get lost in checking the procedure. So I want you to continue repeating to yourself as you're learning this. Check the trig stuff. We saw that I was checking 3 things reliably. It was reciprocal identities, product and quotient identities, Pythagorean identities. Then it was algebra things, which is, can I factor something, can I distribute something, or can I do a common denominator for something? And if you run through that checklist every single time, ignoring the previous thing you did, basically if you distribute something, you're not going to turn around on this step and say, oh wait, I can factor secant x, because that takes you back to the beginning. So you have to think about that checklist, omitting the stuff that just undoes what you just did. You can get to the end of pretty much any identity just from doing that. What these sections are really about, 5.2 all the way up to 5.5, is getting good with that skill. Okay, so let's look at another. Example number 2. We have cotangent squared of x times tangent squared of x plus 1 equals cosecant squared of x. Okay, so for this identity, again, in general, we'd like to pick the more complicated side because it gives us more to work with. So this is intimidating, but, well, it's easier to work with. So, what I have here is a situation where I can actually do this in about two different ways, but I'm going to do probably the one that follows our checklist the most closely. So if you see the other way, which kind of goes out of order with our checklist, then feel free to try it, but I'm going to try to do this the easier way. Okay, so tangent squared plus 1. As I'm looking through this, I'm going to check, are there reciprocal identities that I know? And immediately, there are some, but they're not particularly helpful. Product identities, yes, I could do something here, but it would be out of order with the checklist. It would require algebra first. So I'm going to look for my final kind of idea, which is Pythagorean trig identities. And we notice that tangent squared plus 1 is in fact a trigonometric identity. If we do secant squared minus 1, secant squared minus tangent squared, that equals 1. So tangent squared plus 1 is equal to secant squared. And that gives me secant squared x times cotangent squared of x equals something. Well, notice that cotangent is cosine squared over sine squared, and secant squared is 1 over cosine squared. And here I have a cosine over a cosine, which leaves me with 1 over sine. So 1 over sine squared x is precisely cosecant squared x, which is required of our identity. And there we go. So notice I'm checking for things like reciprocal identities, product quotient identities, Pythagorean identities, and then I go through changing them into sines and cosines and simplifying everything down, and then maybe applying another reciprocal identity to put it in the form that is required of the identity. Okay, let me move to the next one. Okay, so our next trig identity is this. We have tangent squared over secant squared is equal to 1 minus cosine and 1 plus cosine. And we'd like to pick whichever side looks more complicated. Well, I can notice that this is a difference of two squares, and so that's actually not as complicated as it looks. If I can create this as a difference of squares, then that'll allow me to make a factoring move to turn it into a difference of squares in factored form like we have on the right. So it's actually not all that difficult to work with. This, on the other hand, is a little bit worse. We do have a quotient identity on our hexagon for tangents divided by secant, but I can also notice that I can apply reciprocal identities here. So there's more than one thing I can do right here. If I were to start with the right-hand side, I'm basically stuck having to FOIL this out, which is an algebra technique, and we like to do trig techniques before algebra. So we can notice that secant on the bottom of the vinculum is a cosine on top. So that actually says tangent squared times cosine squared. Well, tangent squared times cosine squared, we can notice that the quotient identity for tangent is sine over cosine. So the two cosines on bottom will cancel with the cosines here, leaving us with sine squared here. Well, then we can notice that sine squared plus cosine squared is equal to 1. So 1 minus cosine squared must actually equal to sine squared. So I can rewrite sine squared as 1 minus cosine squared, which is, of course, the aforementioned difference of two squares. And so I can write that 1 minus cosine x and 1 plus cosine of x, which is precisely equal to what was required of us in the first place. And notice that I have this checklist in my head and I'm running through it and I'm trying to avoid algebraic techniques as often as possible. Effectively, the algebra techniques just allow me to change the form that something is in. So when I know that this is the answer, then it allows me to just change its form so that the left-hand side looks like the right-hand side. But that's not like the go-to thing. I'm not going to try to do college algebra things. I'm going to try to use my identity sheet, and I'm going to try to use the trig formulas to do most of the simplification. And yes, there's some algebra happening, like cosine times tangent, but that's also a product identity on our hexagon. Another thing that we should be noticing here is that when we're dealing with like squareds, so like cosine squared, we notice that it's basically just two cosines times each other. So if I wanted to rewrite it as like a reciprocal identity, it'll be two secants times each other on the bottom, so you get secant squared. In other words, we can apply the identities for product and quotient even if it's squared, as long as the number of cosines and the number of tangents are equal to each other, then it will work. It will work perfectly fine. If I were to take cosine times tangent, I would get a sine. So if I take two cosines times two tangents, then I get two sines. And that allows me to apply Pythagorean identities, which should be kind of like the last resort on the trig formula sheet. Okay, so then we have some other techniques that we're going to get into. And effectively, the order goes check your trig identities, then check your algebraic things, and then check alternative techniques. So here we have secant x plus tangent of x over sine of x, which should be equal to, and we'll have the cosecant of x over the secant minus tan, like secant x minus x. Okay, so here we have a pretty serious problem. When I go through my list, give me just a moment here. Okay, so on this one, because we have this kind of funny setup, you'll notice that we have the secant of x over sine of x and the tangent of x over sine of x with a plus symbol on top. And then we'll have this other thing over here, the secant of x minus tangent of x on the bottom. And we have a couple of different ways that we could go about doing this, but none of the identities that we know match anything in this form. They're not Pythagorean. We can do some of the weird like common denominator procedures if we used reciprocal identities to turn these into sines and cosines. But then we're going to run into this problem of, well, how do we do this without manipulating both sides? So what we can do is we can apply an advanced technique, which we steal from complex numbers, a topic in college algebra. So we can use the properties of conjugates to make the left-hand side look like the right-hand side or make the right-hand side look like the left-hand side. And so specifically what I'm going to try to do here is I'm going to use the left-hand side and I'm going to multiply by what we call the conjugate. And the way that we can tell that this is a conjugate problem is you notice that these two parts, the top left and the bottom right, are basically identical to each other. It's just that the symbol is different. So that's kind of the indicator that this may be a conjugate problem. But if you think through the checklist and you look at this, you say, okay, well, we got a problem because I could do some reciprocal stuff, but it doesn't really help. There's no Pythagorean stuff because nothing is squared. And then on top of that, there's no immediate products or quotients that are necessarily useful. I've got like a cosecant times tangent here, and a cosecant times secant, which is nothing. So there's nothing immediately helpful. And then when you look at this, there's nothing that can be factored, there's nothing that can be distributed, and there's no common denominators without first doing some reciprocal identity stuff. So none of the things in our checklist work on this. That's a very strong indicator that we need to use a conjugate. So the conjugate is very, very simple. We just take the additive part, which is either the secant plus tangent, or if we're working with the right-hand side, it's the secant minus tangent. And we multiply by the same thing, top and bottom, with the added thing that we're going to change the symbol. So if this one is a plus tangent x, we're going to multiply by minus tangent x. Now, the reason that this is important is because now if I drop parentheses around the top and bottom, you'll notice that this is a difference of two squares, which will simplify to secant squared minus tangent squared over sine of x times secant x minus tangent of x. But notice that secant squared minus tangent squared is just 1. And I get something that's almost in the correct form. What I've effectively done is I've moved this secant x plus tangent x to the bottom so that it looks like the right-hand side. And the only thing that I have to figure out is how this sine of x behaves. But notice that sine of x is a reciprocal identity. Because this is a product, I'm allowed to do that. So you also notice that I'm checking trig things before algebra. So I'm not immediately distributing the sine through the secant x minus tangent x. That's actually a bad thing. So instead I'm going to say, okay, well, sine is a reciprocal identity for cosecant, so I can move it to the top of this vinculum as a cosecant, which is precisely what I was supposed to show in the first place. Boom, there it is. Okay, so remember, 5.2 is just a gigantic checklist. You will have to practice with this. It's not worth anything if you don't practice with it. And once you have that checklist in mind, remember we're going to try to do trig things over algebra things. And then we have one special technique so far, which is for things that look like this, where none of the things in the checklist actually work for it. And we call that the complex conjugate. And it typically simplifies to where we have a Pythagorean identity that will reduce to 1. And then we'll be left with this thing on the bottom, which we can apply either a product or a reciprocal rule to in order to get it to look just like the other side. So you've seen several examples of this, and we will see several more involving the usage of other identities as we go forward in sections 5.3 up to 5.5. All right, if you understand that, then you've got section 5.2.